In this video, we'll discuss segmentation as the mechanism of memory addressing in x86 processors. To explain segments, we need to go back to the beginning of the x86 architecture history and understand the reason for some decisions made in the initial design. The x86 architecture was created in the late 70 years of the 20th century. The technology available at that time didn't allow for the implementation of advanced integrated circuits containing millions of transistors on a single silicon die. The x86, as you know, were the first processor in the whole family of x86. It required additional supporting elements to operate. This led to the necessity of making some decisions about the compromise between efficiency and computational possibilities and the size of the silicon and the cost. This is the reason why Intel invented some specific elements of the architecture. One of them is the segmentation mechanism used to extend the addressing space from 64 kilobyte, typically available in 60-bit microprocessors, up to 1 megabyte. The x86 can address the memory in so-called real mode only. In this mode, the address is calculated with two 16-bit elements, segment and offset. The x86 implements 4 special registers to store the segment part of the address: CS code segment, DS data segment, ES extra segment, and stack segment. During program execution, all addresses are calculated relative to one of these registers. The program is divided into 3 segments containing the main elements. The code segment contains processor's instructions and their immediate operands. The instructions are related to the CS register. The data segment is related to the DS register. It contains data for the program. The stack segment contains the program stack and is related to the SS register. If needed, it is possible to use an extra segment related to the ES register. The address of each element of the program always consists of 2 elements, the segment and the offset. Such a pair is named a logical address. Both numbers which form a logical address are 16-bit numbers. The question is how to calculate the 20-bit address with 2 16-bit values. It is done in the following way. The segment part, taken always from the chosen segment register, is shifted 4 bits position left. 4 bits on the right side are filled with zeros, forming a 20-bit value. The offset value is added to the result of the shift. The result of the calculations is named the linear address. In the x86 processor, the linear address equals the physical address, which is provided via the addressable bus of the memory of the computer. With the introduction of 32-bit processors capable of addressing larger memory spaces, the real addressing mode was replaced with addressing with the use of descriptors. With 32 bits, it is possible to address 4 GB of linear address space. Segmentation in 32-bit processors can be used to implement the protection mechanism to ensure that processes can operate simultaneously without interfering. Every segment is described by its descriptor. The descriptor holds important information about the segment, including the starting address, limit, so the size of the segment, and attributes. As it is possible to define many segments at the same time, descriptors are stored in the memory in descriptor tables. The 16-bit segment register in protected mode holds the segment selector, which is an index in the table of descriptors. The table is stored in memory, created and managed by the operating system. Each segment register has an additional part that is hidden from direct access. To speed up the operation, the descriptor is downloaded from the table into the hidden part automatically each time the segment register is modified. The 32-bit offset points to the chosen byte in memory. Although segmentation allows for advanced memory management and the implementation of memory protection, none of the popular operating systems, including Windows, Linux, or macOS, ever used it. In Windows, all segment registers via descriptor point-to-point-0 base address and the maximal limit, resulting in the flat memory model. In this approach, the segmentation de facto doesn't function, and all addresses are represented by the offsets only. The offset points directly into the linear address space. Because the segmentation wasn't used by operating systems, software producers, AMD and Intel decided to abandon segmentation in 64-bit processors. For backwards compatibility, modern processors can run 32-bit mode with segmentation, but the newest versions of operating system use 64-bit addressing, named long mode. The only possible addressing is a flat memory model, and addresses are represented by offsets only. Despite the depreciation of segmentation mechanism, the terms code segment and data segment still exist. Formally, they should be called sections, but the force of habit.